Hello everyone, today we are talking about how the lithium mining. So first, what is lithium? Lithium is a chemical element. It is also a soft silver metal. Lithium is 27th most abundant in the nature. There are more than 30 kinds of lithium minerals. Lithium is used in many ways, but we often be finding in the battery. So the distribution of the lithium. Chile has 8 million tons of lithium, the largest known reserve in the world. Between 2008 and 2018 alone, annual production in major producing countries such as Australia, Chile, and China rose from 25,400 to 85,000 tons. An important growth drive is used in the battery of the electrical vehicles. Australia is the most important supplier of the lithium so far in 2018, with 51,000 tons. Mining methods are different. Lithium from Australia comes from mineral mining. Talison Lithium Company is the world's largest primary lithium producer. Production from its Australian operation fills roughly a third of the world lithium demand. The Greenbushes lithium operation has been producing lithium for over 25 years. Greenbushes' ore body length is 3 kilometers. Its mineral reserve is very unique, grading 50% spodumene. Its lithium ore grade is up to 3.9%. Because of the pit's downward extension, there is significant potential to increase the lithium mineral reserve. Unlike the Australia, Chile's lithium comes from salt desert known as salarios. Lithium salt water from the underground lake is brought to the surface, where it's evaporated in the Great Basin. The salaries of Atacama contains 27% of the world lithium reserve base. It's the world's largest and purest active source of lithium. Atacama's finished lithium carbonate is estimated to have half of the lithium reserve in the world.
Due to its high reactivity, the chemical process of lithium extraction is where lithium is separated from the sample and converted into a soluble form of lithium. Most commercial lithium is available in the form of lithium carbonate. Extraction methods currently rely on two main sources of lithium: sulfide brines and oils. The first is described as conventional lithium brine extraction. Lithium brine recovery is usually a simple but lithium process. The mined brine is distributed to the evaporation ponds, where it is retained for months or years, and the evaporation removes most of the liquid water. The potassium and sodium normally contained in the brine are extracted from the evaporation process. When the brine reaches the designed lithium concentration, it is pumped to lithium recovery facility for extraction. The following four steps are usually required. Filtration or ion exchange purification is usually used to remove any contaminants or unwanted contaminants from the brine. Next, chemical solvents and reagents are applied to separate the designed products and the subproducts by the sedimentation. The brine is then filtered to separate out the sedimented solids. Finally, depending on the designed product, different reagents are used to produce a common form of lithium. Once filtered and dried, it is ready for sale. The second type of lithium extraction is from ore. The processing of lithium ore begins with the beneficiation and then its compounds are extracted in the downstream process. The figure shows a general flow chart of the main techniques used in the beneficiation of the lithium minerals. Sequencing may change. Heavy media separation is a pre-concentration technique used to remove mineral. Magnetic separation is used to remove large amount of iron brine vein mineral, making the concentrate suitable for the industrial manufacture. Frost flotation increases the grade of the concentration, while preventing as much reduction in the lithium recovery as possible. Extraction is carried out by crossing and roasting at 1100 degrees. It is then cooled, ground, and roasted again, this time using sulfuric acid to produce lithium sulfate. Finally, sodium acid and sodium carbonate is added, and the resulting lithium carbonate is heated, filtered, drained. A soluble lithium carbonate is formed, while the resulting wastewater is treated for reuse and disposal.
There are many challenges of lithium mining. First challenge is air pollution. Lithium mining uses a large quantities of water and energy. Each estimated 15 tons of carbon dioxide are released for every ton of lithium produced. Second challenge is destabilization of local ecosystem. Mining, lithium mining also causes change or scar on the landscape. As a result, the growth of the region is prevented. Third challenge is water pollution. Lithium mine byproducts such as magnesium and lime waste are mixed with water sources, cause an exceedingly alkaline river water. As a result, it contaminates surface waters and drinking waters and kill aquatic life. Approximately 2.2 million liters of water is needed to produce 1 ton of lithium. Fourth challenge is water scarcity, cause less water supply because mining sites overlap with nature conservation areas. As a result, the process of forced migration of population from villages and the abandonment of essential settlements. Fifth challenge is competition for control of lithium supply. Governments are fighting for supremacy over lithium because lithium has high demand in market. As a result, wars, conflicts, and rise in corruption occurs to control lithium resources. The final challenge is legal action on lithium mining projects. Indigenous people have not been properly consulted and their concerns have not been properly solved. As a result, these people have taken legal action over lithium project violation. Consultation are requirement under the ILO Convention 169 on Indigenous and Tribal Peoples.
So far, we know that lithium is a metal with special properties, so there are necessarily many challenges in processing the ore to extract it. In this section, we will first understand the main current challenges and then see if there are new technologies that can address them. The sulfuric acid method is one of the most commonly used one, and we can see from the graph on the right-hand side, the extraction rates are dependent on temperatures, which suggests that this method requires high temperature conditions. This is also a large amount of strong acid, so it leads to a high energy consumption and corrosion of the equipment. The limestone method also requires high temperature calcination, so it leads to high energy consumption. Also, as the lithium ore and limestone are mixed during the processing, this makes the recovery of lithium not very high. The sulfate method will result in high recovery of lithium carbonate rate, but this method is not only energy intensive, but also has a long process flow. The chlorination roasting not only produces corrosive gases, but also makes it more difficult to separate and collect the lithium chloride gas. This leads to high demands on technology and equipment. So the ash pressure cooking method, requiring high temperature and pressure, causes high energy consumption and high requirements for reaction conditions. The great shortcomings of existing extraction methods has been noted and attempts has been made to find new methods to solve it. One new method is lime-based evaporation. Most of the unwanted sessions are spontaneously precipitated under daylight evaporation. However, because it relies on solar energy, the process is subject to environmental influences, and the efficiency is very unstable. Another new invention, iron sieve absorption. is an electrochemical extraction method based on lithium-ion batteries. This can help avoid the need for high temperatures and pressures, but the powdered iron shifts result in a method that is not very efficient. In conclusion, at the current stage, there is no perfect method of processing, but fortunately, people never give up to find new methods.
Okay, let's talk about the lithium's usage in a global market. As my partner says, the lithium's physical and chemical properties make it useful in many industry, especially for the battery industry. As a Paris Agreement, there is a global focus on green gas emission in order to control the climate change. Vehicle emissions are one of the main contributors to greenhouse gas production. To solve this problem, more and more rechargeable cars are launched, such as Tesla. And these batteries can be used not only in the vehicle industry but also in medical devices and other industry which needs use of batteries and so on. From this graph, we can see that the consumption of lithium in 2018 has exceeded half of the total consumption in battery industry, while in 2030 it is expected to account for 90%, and the total consumption will also increase greatly. Although the impact of COVID-19 on manufacturing has led to low growth rate in the lithium market in recent years, the demand for lithium will rise significantly once COVID-19 is over. However, this leads to supply of lithium cannot meet the demand, and at the same time, the price of lithium will also rise. This lithium's production is expected to rise 20% per year. However, this is the future that can only be achieved with the good development of lithium batteries. So in fact, first of all, there is a problem of the at some point in next few years, the production of lithium may not reach the consumption rate. In this case, the second point is about the research and development is particularly important in the lithium industry. Scientists are already studying how to more directly extract lithium and improve the recovery rate of lithium. They are also studying how to extend the life of lithium batteries and automate the manufacturing of lithium batteries, which can help increase of the lithium's market size and make the supply make the demand. And third point is about the replaceability of lithium. The fact that the use of increased because it can be used as battery for this reason. The United States recently developed a new sodium-ion battery looking to replace the lithium battery. Due to the content sodium in Earth is small and easier to extract than the lithium. Also, the seawater batteries are more accepted by the social. With lithium batteries, if not recycled in time, it can be a great impact on Earth's environment. While sodium smart battery compared with this problem are smaller impact on that. So in short, if lithium want to be competitive in the market in the future, it should do following three things. Firstly, improve the production rate. Secondly, do the research and development of lithium batteries with least impact on the environment, improve the processing. And third is develop the recycling better longer life of batteries. At the same time, the lithium developers can also cooperate with companies such as Tesla and also signed with the agreement to regularly provide the battery with them. In conclusion, generally, lithium is abundant and can be used in many industries. Although it causes environment pollution when it is extracted, it is non-polluting energy sources when it is used, and it also need to be noted that recycling of waste lithium batteries. In today's growing demand for lithium batteries, the market share of the lithium will always increase as long as it is not replaced. So the in research and development is really important for the lithium industry, whether it is in the development of more efficient production method or in it or in the management of the production pollution and use. That's all. Thank you. Here's our reference.